So here's a ruler I have, and it's very thin, as you can see. So if I apply a compression force, what's going to happen is this ruler is going to bend, right? Can you see it's bending? So this is exactly the same thing that happens when we're doing the design of cold formed. It's very thin, so it bends. It doesn't need a lot of stress to bend. And there are different ways that this bending or this buckling can happen. One of them is local buckling. So as you can see here in this image, and local buckling is very tricky because it can actually happen over short lengths, even 60 centimeters long. So when you're talking about shed design, so to quickly open ShedMate here to go through this process with you. Zoom in a little bit. So for example, local buckling could happen every 60 minutes. So no matter the amount of fly bracing I put here, we could still have a local buckling because it's every 60 centimeters. And we don't want to do bracing every 600 millimeters. That's not practical whatsoever. So this is something that we assess when doing the analysis. The other one is distortional buckling, which is the cross-section shape changes through the rotation of flanges and webs. And then we also have the global buckling. That's where the entire member deforms without changing its cross-sectional shape. Once again, I don't want you to be very worried about the complicated terminology here. I just want you to understand that buckling exists. Remember the ruler? Buckling exists, and this is what we assess very consciously when doing the design of these types of buildings. Let's move forward because that gave us that base. So, okay, Arthur, you're talking about all of that BS of buckling. What does that mean for me? It means that this is why you need bracing. I've talked to some shed businesses who they don't like bracing at all. I know it can be a pain to erect, but if you don't have bracing, you need thicker materials. Remember, you need a thicker ruler so it doesn't do this, right? So this is the price you're paying. If you need a light design, you need bracing, right? So you need knee bracing, you need roof bracing, you need wall bracing, you need fly bracing, because the fly bracing, knee bracing, all of that is going to act as an item that's going to reduce the total length of that specific ruler. So now I need to put a lot more strength to actually bend it. But if I have the item there, just like a rafter, look, this could bend very easily. But when I add a fly bracing here, then, okay, it becomes harder to do it. So this is pretty much the principle around it, right? So an engineer will specify the bracing to reduce the buckling lengths, to control sway, and to satisfy code requirements.